but we're really going to get hardcore into it. Before I get into an angle, let me introduce what's called a ray. A ray. Day 2, I introduced a line. What do you got to have on the end of your lines? Arrows, correct, because if you take it off, take both arrows off, what's it called? You now know? Segment. All right, well, what if I leave one arrow on and take one arrow off? That is now called a ray. Okay, that is called a ray. So we have an endpoint followed by the arrow. All right, I take one of those arrows off a line. You end up with a ray. Let's start labeling with some letters now. This will be point D. Let's put E on here, and let's put F on here. When we talked about a line and a line segment, honestly, order didn't matter. You could have put the letter, the points any which way you wanted. Not anymore. Order matters when you start writing the symbols. So the little symbol is a little ray, yeah. But what you put under it does matter. It matters. You have to put the endpoint first. Wherever the ray starts, the endpoint, you have to put that point first. There's no negotiating that. After that, you can put any point following it. So DE, DF, but D has to come first. Okay, it has to come first. So if you want to make a note, we could have called this DF as well. And a little note here for everyone, endpoint must come first. Okay, so now you have a line segment, and now introducing a ray. Questions on array? Because we're going to put two together in a second to make something brand new. Put two rays together. All right, last little thing about rays, you can have what's called opposite rays. I use a new vocab in the definition, collinear. What's that mean again? These rays are going to be on where? Same line. All right, these rays are going to be on the same line. So make yourself a line right now. Go ahead and make yourself a line. And on that line, let's put Z, X, and Y. In my diagram there's two opposite rays. There are two rays that are opposite each other. They're on the same line, and they have the same endpoint. They have, do you see two? I see a bunch of rays, but I see two that are opposite because they share the same endpoint and go up in opposite directions. So I'll give you one of them, you give me the other. I'll start here with ray XY. There is another ray that is opposite XY. Make sure you name it appropriately. It's got to have the same endpoint, right? They share the same endpoint. XY and, here we go. Let's start this off right. XY and Taylor. Good job. Notice what's first, X and X. Good work. Okay, any issues with rays? Because now I really want to get into the big part of today is when I put two rays together. All right, let's do this. I put two rays together, I get an angle. All right, two rays together, I'm going to get an angle. Now, I don't mean opposite rays. Here you go. One ray, second ray that share the same endpoint. Welcome to an angle. There's a bunch of things I want you to put on this angle. Let's put N here. And let's put P on this ray. And I'm about to put another letter. Do you see where the two rays meet? Do you see the point they have in common there? That's called the vertex of the angle. The vertex of the angle. Right here, I'm about to label M. That's the vertex. That's where the two rays are going to meet each other. Vertex. And then inside the angle, can you put a little number 2 right inside the angle there for me? All right, let's talk. How to name it. How to name an angle. All right, how do I name it? There's 3 different ways. One way I love the most out of the other 2. But first way, you can name it by its vertex. What's the vertex of this angle again? So I could call this angle M. So what's the symbol I want you to use for angle? You can use that. Or sometimes you'll see me use that with a little arc mark through it. I use both. It's just how I'm feeling that day. I don't care which one you use. They're both correct. And we said we could name it by its vertex. So we can name that angle M. Sometimes, very rare, we can name it by the number inside. All right, we can name it by the number inside or the lowercase letter. That's very rare, but sometimes it does happen. So we could also refer to this as angle 2. Okay, very rare though. Very rare. Just throw it away and get going with your notes. And then next up, this is the way I would prefer. This is the way I would prefer all of you do it. You name it with the 3 capital letters where the middle letter is the vertex. Middle letter is the vertex. So we could go here, angle, everyone ready? N, what's the vertex again? So I gotta put that in the middle. NMP. Could I go PMN? Yes, as long as what's in the middle? My vertex. All right, I prefer that way. You'll see why as we do a bunch of problems. Questions on how to name an angle now or what symbol to use. You don't have to have my little arc mark there. That's just how I roll sometimes. No questions? All right, different types of angles. I think you are familiar with these, I believe, I hope. All right, start off with me. Right angle, what do you know about it? Right angle? Nothing? What do you got? 90 degrees, right? Measures exactly 90 degrees. Perfect. Measures exactly 90. That's great that you know that. More importantly for me is what it looks like. And how do you know it's a right angle? So let me do this. I have no idea that's a right angle. You don't tell me because it looks like it. Anybody know what's got to be there? What has to be there, Noah, that says, darn it, that's a right angle?
The square, the little square.
The little box, the square, whatever you call it here. This tells me that is definitely a right angle now. Heard of a straight angle before? Straight angle? No, that's a new one. What do you got, Warren?
Just a line, 180 degrees.
It measures 180. It's another name for a what? You already said it.
Half circle.
No. A line. That's all it is. Measure. That's all it is a line. Okay, measures exactly 180 degrees. And that's all it is a line. All lines measure 180 degrees. How about acute? Acute? Anyone? My hopes are acute. What do you got, Taylor? Okay, that's true. I'm going to put a little bit more between 0 and 90. Okay, and some of you are going to say, well, how can anything less than 0 be an angle? Next year, you'll find out in Algebra 2 that you can have negative degrees. Measures between 0 and 90 degrees. Yep. And I have no diagram there for you. How about obtuse? Obtuse measures between, what do you got, Connor?
90 and 180.
No, 90 and 180. Yep. Anything between those two bad boys. Yes, you can have something more than 180. You'll find out next year. All right, everyone. All right, the different types. How do I make one with my compass now? Right? How do I make an angle with my compass? All right. Before we do that, what were congruent segments? I'm going to start quizzing you guys now. When we talked last week, if 2 segments are congruent, what did you know about them? Anything. 2 segments are congruent. Taylor, going back to you, it looks like.
The same.
Same length. Right? Everyone else agreed? They had the same length. Perfect. Great job. They had the same length. You guys have this or no? Yeah, you guys have it, right? Congruent angles. Now, congruent angles don't have length, they have measure. So they have the same degree measure. 2 angles that have the same degree measure. All right, so draw me 2 angles that look congruent, please. 2 angles that look congruent. On the segments, what markings did we put on to say that they were congruent last week for segments? We knew they were congruent, so we put on what markings here? Here we go. Ooh, one job. You here? Next up here, Evelyn. Again, Evelyn, what do you got? Hash marks, good. Well, I can't put hash marks on angles. Can't do that. Instead, to show if two angles are congruent, we put arc marks right next to the vertex. Okay, we put arc marks right next to the vertex. So that tells me that they are congruent. All right, everyone, we got hash marks for segments, arc marks for angles now, that they have the same degree measure. We all good? All right, it says construct. We talked. The time to pick up our compass and straight edge now. Construct an angle that's got the same measure as angle A. So I want an angle that's got the same degree measure as angle A, but with the vertex at B. All right, first step is the same first step we've had with congruent segment, double a segment, add a segment, subtract a segment. What did we always draw first before we even picked up the compass? What do we always draw first, Sim?
A line.
A line segment, right? So everyone give me a line segment, please, starting with B. That's what we always start off with so far. That'll change soon. All right, everyone ready? Put your compass point on vertex A. Put your compass point on vertex A, the angle we are about to copy. And I don't need anything huge. When students start getting huge arc marks, that's when trouble happens. Try to keep them small. You are going to make an arc through both rays of your angle. Watch me do it here. You're going to make an arc through both rays of your angle. Does not need to be huge. Do not open or close your compass. Keep it that same opening, please. So make an arc that intersects both those rays. How are we looking, all right? Okay. Real quickly, keep your compass the same opening, but take your pen or pencil and put points on where they intersected those rays, because that's going to come into play next step. So just put points on where they intersected. Okay, come on over to your line segment we're doing the construction on. Put your compass point on B. And using that same opening, you're going to make another arc that intersects the segment. And just like you did for the angle, put a point on the intersection of the segment. We all good. All we did was make an arc, make the same arc, right? All right, last step. Remember I had you put points of intersection here? That's because you're going to take your compass and open it up to those 2 points of intersection right now. You do not need to make any arc marks. You are just opening your compass to those 2 points of intersection. Okay, open it up. Then, here's the part you have to remember. The finisher, come on over. Do not put it on B. That's why I had you mark the point of intersection. That is where you're going to put your last compass mark here. So put your compass point on B, on that point of intersection. And here's what you want to do. You want to make an arc that intersects that first one you made. I don't care if it does it above or below. It does not matter. Make them intersect each other, please. If you are finding out that they don't intersect, you might have to go back. Hey, you might have to go back and make this first one longer. That's okay. Go ahead and make it longer if they don't intersect. But you need to make it intersect above or below, coming from this point. All good? Okay, grab your straight edge. And draw in the other part of your angle now. One part's your segment. Here's the other part. Oh, wrong way for me. There's the other part. Some of you may look at this and be like, wow, This one is so much bigger than that one. They can't be congruent. You don't understand what congruent is. What's congruent? For angles, they have the same measure right there. I bet you if we took a protractor and measured it, they'd be the same amount of degrees. All right, questions? All right, one doesn't make you great. That's for darn sure. Find somewhere. Whoa, we're not going on. Find somewhere up in the white space in the top right-hand corner up here of this same page. Just freehand, draw yourself an angle right now. Draw yourself an angle up in the top right-hand corner of that white space that you have. And I'm going to walk around and watch you copy it. Construct an angle that's congruent to the one you just freehanded right now. Okay? Don't make those until you make your arc mark. Then you put those on where they intersect. Make sense? Okay. So draw yourself a segment. Put your compass on the vertex. Make an arc through. If you forget the steps, let me know. That's why we're practicing on our own right now. Just put it in the car loops. We're good here. Let's get rolling with the notes. Need a compass. What? There we go. We gotta get one here. You can't freehand it. Okay, you can't just draw one that looks like it. All right, I need those arc marks. I need to see those two arc marks intersecting. Make sure the last step, you are not going from your endpoint. You are going from where the arc intersected your segment. That's the big thing. Another minute. All right, let's roll here. Measure the opening. Where do we put the compass point now? Yep. Try to make it, if it doesn't intersect the first one, then you gotta go back and make the first one longer. If it doesn't, yep, go back, make the first one longer, and then draw your ray through that point of intersection. We got it. How we feeling, all right? Because I gotta do another one here with you. Not another copy and angle, but maybe that'll be good. All right. Everybody here, we're all right? Copy and angle before I move on. Also, I got a little sloppy up there. How are you gonna know my angles are congruent? What's our new markings now? Let's start putting our markings. What should I be putting up on there, Warren?
Arc mark.
Arc marks, yep. And you guys that just did it on your own, how many arc marks do you think you put on yours so we know that these two are congruent and then the ones you just did were congruent? Yeah, darn right. I should be putting 2 on the ones you just did to show that this set's congruent, but my set is also congruent with the 2. Any questions, comments, or concerns there? All right, next up. Now, here let me stop here and let's take a deep breath. Some of you might have done really well on the quiz and you're understanding this whole angle stuff right now. Great. I will let you know this is the point in the unit 1 where some kids start going downhill quick because I'm throwing too much vocab at them. All right, please keep it all together somehow. All right, come in for extra help if you need, use the flashcards, or if it is that much overwhelming, let's think about a trip down to geometry instead of staying in AB. All right, I will let you know just from past experience teaching this course for so many years, this right now, once I introduce this new vocab, this is when it starts going downhill because it's too overwhelming for some of you. All right, let's try to keep it straight. All right, here we go. We have an angle. Now, I want to take that angle and cut it in half. All right, I want to cut it in half. And I'm going to cut it in half with a ray. All right, so I have an angle, 40 degrees. I want to cut it into 220s. All right, I'm going to do that with a ray. And that ray is called an angle bisector. All right, let me say that again. Angle bisector. It cuts an angle in half. Okay, it cuts an angle in half. Everybody good? All right, first thing I'm going to do is how to construct it. So grab your compass. I have angle eight. Actually, you know what? Let me quiz you real quick. How would you name that angle up there? A couple different names for that angle up there, based on what we've already talked about today. How do you name that angle? Here we go. Leo, how would you name that angle? BAC. Good. Give me another name for that angle up there. Leo, again. CAB. I could also name it angle A. Everyone agreed? I can name it just by its vertex. All right, perfect. Now, how do I cut this in half? New thing here. Every time I've done a construction with you so far this year, do not write this down. You guys have drawn a segment for me, right? Well, I don't need that because I'm cutting that angle in half. So all my arc marks are going to be on that angle and that angle only. I don't need a separate segment because what am I asking? Cut that angle in half, not a new angle. Cut that one. You ready to go? How to do a bisector? Put your compass point on A. Put your compass point on A for me. Similar to what we just did for copy an angle, make an arc through the two rays. Nothing huge, please. Nothing huge. Make an arc through the two rays. Label those points of intersection, please, with points. Take your compass, put it on one of those points of intersection. And right above that arc, again, we don't need huge arcs. Keep them small. We're going to make a second arc above it. It does not need to intersect the first. And you can leave your compass the same opening for all steps here. So you've made an arc above, right? Everyone's good? Please put your compass point on the other point of intersection. Right now it's on the one point. Now put it on the other point. And here's what you want to do. Make a third arc that intersects the previous one. That's it. So this first arc was just to know where to put your compass. Now you're going to make two more arcs above it that intersect. Looks like fireworks. That's my nickname for this one, fireworks. Make an arc through your angle. And then from each point of intersection, make two more arcs that intersect. If any of you are at this point right now, I'm going to walk around and help you out. Grab your straight edge. And then from vertex A and your point of intersection, draw yourself a ray. All right, draw yourself a ray from vertex A through the point of intersection. Okay, where are we? Put it on that point, right? Make an arc above. Yep. Now go to this point here. You make your. Where did this come from? This point or this point? That came from here. Okay, so make sure. Okay, we're good here. Now you go to this point, and then make it so they intersect. If they don't intersect, you got to go back and make that first one longer. Okay. Others, we're all right. Before we put some proper labels on these bad boys. You have just cut that angle in half. All right, which means if that's 20 degrees, that angle's 20 degrees. If that's 60, that's 60. Meaning, what markings can we put on each side of the ray now? Arc marks, darn right. And here's what I always do here, just be careful. I always offset them so it doesn't look like one full arc mark, all right? I just do a little offsetting arc marks there so you can definitely tell those two are congruent. Bisects, cuts it in half. Get that going. Bisects, angles being cut in half. Questions on how to do it? We don't have time for you to practice because I got to go over some algebra ones. Any questions there? The constructions are piling up, aren't they? Okay, they're piling up. Let me know if you need to come in and get a little practice with them. All right, let's do some algebra with bisectors to finish up today. Or do we have? Oh, I did it on the wrong one. Huh? Would I have a double one up there? Double slide. All right, here we go. Algebra with angle bisectors. First, we need to get into this habit. Woo! Nope, not going to read it. I got to read the directions because the directions are probably going to contain some vocab that we've talked about. KJ and KL are opposite rays. Good, we know what those are. They go in opposite directions, form a line. What's KN though? What is KN? KN, keep reading. What's it do? Bisects. What are we thinking? Bisects. What's it doing to the angle? Cuts it in half. Right now, I need to find, everyone in this class, find angle LKM right now. Trace it with your finger, trace it with your hand. Doesn't matter. Find LKM. Find that angle right. You don't need to do anything with it, just find it. Because that's the first piece I got to work with you on. Can you find an angle? Does everyone see LKM? LKM, just follow the letters, LKM. Everyone see that angle in those two rays? All right, I'm going to erase this real quick when I put it up here, but I just want you to see LKM. Everyone see that angle? All good. All right, I know this is like very elementary schoolish, but this is where kids struggle, is finding the darn angle. What is KN doing to it? What is KN doing to it? Whether you read me the directions or in your own words. What's KN doing to that angle right there? We're going deep. Alex?
Bisects.
Okay, what's bisect? So it gets what?
Cuts in half.
Cuts it in half. So right now, I'm going to walk around. Can you put two arc marks on the angles that are now congruent? Because KN is cutting LKM in half. And you put two arc marks that show me arc marks. We're done with the compass and straight edge. Put it away. With your pencil or pen, LKM is getting cut in half. Where should your two arc marks be? And I apologize if this is going too slow for some of you, but I need everyone on the same page here. You should have two arc marks that say these two angles are the same. Kind of offset them a little bit, right? So that doesn't look like one full one. Great, guys, good. Sorry if it's taking too long, but this is where we crawl before we walk. Good, perfect. Guys, that's what you got to do before you start a problem. You read the directions, you put those darn arc marks down immediately because you know what bisects means. That's going to make this problem a whole lot easier. Okay, so everyone's got them here and here. You ready to roll? All right, now we can do the problem. The measure, everyone see that little M right there? That means measure. Okay, measure of LKM is 7x minus 5. Fine, you guys already found LKM, right? That's that whole angle right here. 7x minus 5. From here to here is 7x minus 5. That whole angle. NKM. Guys, find that angle for me. NKM. Can you find that angle? NKM, and put 3x plus 9 in there. 3x plus 9. Pop that bad boy in there for me. What's the measure of LKM? Meaning how many degrees? Degrees. So we need to set up an equation with the 3x plus 9 and the 7x minus 5 to solve for x so we can find the angle measure. Ooh, baby. whole thing's 7x minus 5. That angle's 3x plus 9. And we got to find what x is so I can find the degree measure. Whoa, whoa, whoa! Didn't you guys just put those little markings there, those arc marks? What's that tell me? Those two angles are what? The same. And you just put 3x plus 9 on one of them. I know the other one's blank, because what do I want you to put there? 3x plus 9, because they're both the same. So if you're going to label that one 3x plus 9, we better label that one 3x plus 9. And if I put the two together, what do I end up getting? The whole angle, which I already know is what? 7x minus 5. Someone write an equation so we can solve it right now. Let's write an equation so we can solve it. Those two angles add up to the whole one, which I already know all three of them. Here we go. Help your class out. Here we go. That's me. What do we have? Whoa, whoa, whoa. You're getting wet. Don't show off. Stay one at a time. Don't combine anything for me. Yeah, go ahead. 3x plus 9 plus 3x plus 9 equals 7x minus 9. There you go. Thank you. Thank you. Good. I told you last week I can't help you solve that. All right, that's your algebra days. Go ahead, solve for x for me. Solve for x. I'll ask somebody what you ended up with when you solve for x. Got to know what bisects means, right? When you have the value of x, let us know. Take your time, though, if you don't have it right away. Leo, back to you. Good job. 23. X doesn't make you a winner. It says, what's the measure of LKM, which we labeled 7x minus 5. So this is now substitution. Substitute in Leo's 23, and I'll ask somebody what they got for the measure of angle LKM. How many degrees? When you have it substituted and calculated, let me know. Take your time. John Carlo, 156 degrees. There it is. You can put the little degree symbol there if you want. It doesn't matter to me. Any questions on where that came from? That doesn't happen unless we know what that means. Okay, bisects. That's being cut in half. All right, ready for the next one. Still being cut in half. Still being cut in half. Just some new values up here. Get rid of this stuff here. Okay, so still being cut in half, so I still got my congruent marks. Ready? NKL. NKL. Everyone find that angle for me. NKL, 7x minus 9. N to K to L. 7x minus 9. Pop it in. And also JKM, find that angle. JKM, trace it with your finger, whatever gets the job done. Follow the direction of the letters so you can find where the angle is. JKM, everyone's labeling that. Hopefully x plus 3, looks good. And we need to find how many degrees are in JKN. Find that angle, JKN for me. J to K to N. Ooh. So that one right there, we got to find how many degrees are in that angle. All right. My first question, are x plus 3 and 7x minus 9 equal? Can I set them equal to each other and go? No, there's not arc marks there. Sorry, that ain't happening. Is there anything you can add to the diagram? We labeled the 7x minus 9 and the x plus 3. Is there anything else you can put on the diagram? Anything else you want to put on the diagram here? Because I already know that's 7x minus 9 and that's x plus 3. They're not equal, so that's out. Anything else we can add to the diagram yourself here? I'll get to you. Sam, anything? What do those arcs mean?
It's even. It's congruent.
Okay, what did I put on the 1? How did I label the 1? With what? 7x?
Minus 9.
Okay, so what can I put on the other congruent mark?
7x minus 9.
Yeah, everyone's they're congruent, which means they have the same measure. So that's 7x minus 9. But I know some of you might want to do this. Does this make any sense solving this? Absolutely not. Absolutely not. It's going to get you nowhere other than frustrated. There's a reason why we have all three here. There's a reason why we have all three. And this is going back to a definition we had earlier. What's this bad boy right here? What is that? What is it, Warren?
A straight angle.
It's a straight angle. It's a line. If you need to go back in your notes, what's a straight angle measure or a line measure? How many degrees in there, Adriana? 180. So all three of these add up to the line, which is 180. Write the equation now for me. If all three angles put together equal that line of 180 degrees. Put them together for me. What do you end up having here? Jane, go ahead. What do I write?
X plus 3 plus 7x minus 9 plus 7x minus 9 equals 180.
There we go. All three angles end up forming a straight line. Whew. But you had to put in the 7x minus 9 on your own. Go ahead and solve for x. When you have x, let us know. Take your time though, Alex, when you have x. 13 is x. Not what I was looking for though for the final answer. I'm looking for JKN. So does everyone see the two places you need to substitute in 13 to get to JKN? All right, I'll let you guys do you. Substitute that in. Okay, once everything's substituted in, take your time. If you're still working, Evelyn, let me know what that angle is when you're ready. 90, I didn't hear, and the end of it. 98, good, yep, good work. All right, hopefully if you guys didn't get 98 or have no idea what's going on, you plug in 13 here and you plug in 13 there and add the two together. Good. All right, I don't want you to pack up, but I do want you to turn to the next page, please. Turn to the next page. We are going to save that problem for the beginning of tomorrow's notes, but look down. Whoa, please don't pack up. Look down at tomorrow or tonight's homework, please. I want to show you exactly what I'm talking about here, so there's maximum success tonight. Everyone seeing gave you guys the little asterisks there in addition to the given information. Make sure you notice the markings on the diagram. Let me show you what I mean. Because everyone doesn't see it and they have no idea how to do the problem. Not that. Okay, this one is one of the diagrams tonight. I don't know if you guys, especially in the back, can see it, but the book provides arc marks here. Does everyone see that? So what's that mean about them? They're congruent. And it also says BH bisects EBC, so you're going to have to put your own markings on. Okay, so notice that tonight. They tell you these two are congruent, but there's another two congruent based on that direction right there, and you guys have to find it. All right, before you do those problems. All right, I'm not after school today, but Tuesday through Friday.